What is an activation function in convolutional layers? Imagine you're trying to teach a computer to recognize your favorite photos. It needs to decide what parts of the image are important. That's where activation functions come in. They help neural networks understand what to focus on. In convolutional neural networks, which are a special kind of deep learning model, the process starts with convolutional layers. These layers slide filters over images to find patterns like edges or textures. But just doing that isn't enough for the network to learn complex ideas. It needs a way to decide which signals to pass along. That's the job of an activation function. After the convolution operation, the network applies the activation function to each value in the feature map. This step makes the network capable of learning more complicated features. Without it, the network would only be able to recognize simple, straight-line patterns. Activation functions add the nonlinearity needed for the network to understand complex data. One of the most common activation functions used in convolutional layers is called the rectified linear unit, or ReLU. ReLU takes any negative number and turns it into 0. If the number is positive, it stays the same. This simple rule helps the network learn faster and prevents problems called vanishing gradients, which can slow down training. Other activation functions include the sigmoid, which squashes values between 0 and 1, and the hyperbolic tangent, which scales values between -1 and 1. But ReLU is popular because it is simple and efficient, especially when training large models. Activation functions are essential for many tasks like recognizing objects in images, detecting faces, or even generating new images. For example, models like DALL-E or Midjourney use convolutional neural networks with activation functions to create detailed pictures from text prompts. Even though activation functions are a technical part of neural networks, they also raise ethical questions. For instance, if the network learns biased patterns, it can produce unfair or misleading results. Choosing the right activation function and training the model carefully helps avoid these issues. In short, activation functions in convolutional layers tell the neural network what signals to keep and what to ignore. They introduce the nonlinearity that makes deep learning models powerful. Without them, CNNs would be limited to simple pattern recognition, and that would hold back their ability to understand complex images and data.